And we are live. Hi, everyone. Welcome to On.NET Live. My name is Cecil Phillip, and welcome to the show where we talk about all the great things that are happening around the world of .NET. Today, I have my friend Nish with me, and we're going to be talking about microservices, microservice patterns. How can I get started with microservices in .NET? But before we even get into that, Nish, why don't you really quickly introduce yourself to our folks and let them know a little bit about who you are and what do you do?
Sure. Hey, Cecil. Thank you for having me on the show. Hey, everyone. My name is Nish. I work on the .NET team, the community team specifically. I'm a PM. And I focus on .NET architectures. So if you've seen the architecture reference guides, cloud native apps, microservices, we have a bunch of resources which I'll share about later today. I'm joining in from the city Bangalore in India. So it's very exciting. Happy to be here, Cecil.
And Nish, I really appreciate you joining us because I know it is you can call it early in the morning or late in the night, but it is not a regular time for you to be up. So I appreciate you staying up and being here with us.
Absolutely. Pleasure's mine.
Yeah, so my job is to make sure that you don't fall asleep while we're doing this. Absolutely. And for all of you that are on the stream right now, I know a lot of folks here are coming in from different parts of the world. We also appreciate you too being up, whether it's really late in the morning or really late at night. Hopefully this will be like a really great presentation, and we'll be able to share some great stuff with you. Yep. Now, first thing I want to do, first order of business, is I'm going to share my screen really quickly, and I want to talk to you about some really cool links that I want to share with y'all folks. So first link I want to share, we just released a video today about GRPC Web. Now, this video is available over at Channel 9. So if you head over to channel9.msdn.com and you look for our On.NET show, right? Not our On.NET live show, but our On.NET pre-records that we release videos every week on. You can go ahead over here and check this out. And this is with James Newton King, and he talks about how we could do gRPC Web, how we can call gRPC services from the web browser using .NET, right? So we talk about Blazor, we talk about proxies, and all kinds of great stuff. So if you haven't seen it yet, I definitely recommend you go and check it out. And Nish, I know we're talking about microservices, right? And I'm guessing gRPC might come up a little bit later on, right?
Absolutely, yeah. We'll talk about it briefly.
Right. And the other really interesting video that also came out today that I wanted to share with everyone. So on Visual Studio Toolbox, and this is also on Channel 9 as well, like they released the first part or the first few parts of the series where they talk about building .NET Core project templates. So like these are the templates that, when you're using the CLI and you do .NET new something, right? Like these are the templates that'll like scaffold out your project or create new files and those types of things. And, by default, we get a lot of these templates out of the box. But I think it'd be really cool if we could be able to create our own, right? And really understand like what it actually takes to do that. So I know Syed and Leslie here talk about it. There's a few videos, already released that talk about it as well. So definitely recommend you go ahead and check those out. And Nish, I might even ask you too, like if you could create your own .NET new template, like what kind of template would you want to create?
That's interesting because I think everything related to microservices is already done. So
right.
There's web APIs, gRPC and things. I think there's one interesting thing that I saw from Hanselman tweeted this, I think, .NET new get ignore. That's a very interesting thing that we have it now. Yeah. So I don't know actually. What would you do, Cecil? What would you create?
I've been really interested about like the idea of creating multi-project templates. You know what I mean? So when I say that, I mean, most of the time you do a .NET new something, you get like one project file and one project, like one project in your solution. I think it'll be interesting to create like some more opinionated templates where I do like .NET new microservice project, and then it creates like a YARP project and a web API project and a Docker file or Docker Compose files and like multiple things, right? Because we're probably going to need to create multiple projects anyway, but like create it in a way that a lot of this stuff is already wired up, right? So I already have my open API stuff set up. Maybe I'll have some Kubernetes like defaults, default YAML files already created for me or something like that. At least like anything to kind of make it easier for me to get started building some of those types of things. So I think something like that would be really interesting.
Yeah.
And the last thing I want to share with everyone, so I keep talking about this every week. .NET Conf happened. It was on November 10th through 12th, but the fun is still happening. Everyone is having all these global events, across the world. So if you head over to .netconf.net/local events, you can come here and see if there might be any events happening in your part of the world. So you can see here we have a few happening in Australia, in Austria, France, Sweden, Germany, Ecuador, Italy, Vancouver, Canada, Quebec, Japan, all over the place. So if, there might be a .NET Conf somewhere near you, so make sure you go ahead and check it out. And, there might be something interesting for you to go attend.
Look at the map out there. It's so many purples, .NET purples everywhere.
Yeah, there is a lot of stuff happening inside of here. And then look, Nish, it looks like you have a lot of stuff happening over here in your side of the world too.
Yeah?
Like there's a whole bunch of, if I can scroll into this map a little bit. Oh, too much, right? Like you can see like there's tons of events happening on your side of the world too.
That's true. I signed up for a couple of them. So yeah, it's going to be interesting to see.
Are you hosting any, or are you just kind of taking
I'm
part?
speaking there. We'll be talking about microservices and all kind of things. But hosting, because I am part of this community here. I was hosting events here. I was an MVP before I joined Microsoft. So we are just a large team doing a lot of community stuff here. So it's been quite a while doing that. So
cool. And I see some folks in the chat are saying, please share the links. We will share the links, I promise. Just give me like 2 seconds, and then I'll have them up for everyone to go ahead and click on them. Now, that being said, Nish, why don't we kind of get into the conversation of the day, right? Which is about microservices. I kind of feel like it's hard to be in the industry today and not at least hear about microservices, right? I constantly hear about Docker and Kubernetes and monoliths versus focus services and domain-driven design and all these kind of things. And I know for a lot of folks that could be a little overwhelming sometimes. Like, where do I start? Like what is important for me to know? You know what I mean? Like there's so many different components and tools and things of that nature in the space. Like what are the things I really need to pay attention to? And so I'm hoping that you can help me answer some of those questions and figure out, well, what's the best way for a .NET developer to get into the world of microservices?
Absolutely. So we'll start with microservices. I think what I want to really focus on is we have a bunch of resources out here on the .NET website, and I want to share that with you first, and then we can go in depth as much as you want. Or I'm trying to keep it simple so that when we get started, we don't want to look at the complexity, because microservices in general are complex, and there's a reason for that, right? We're talking about scalability. We're talking about hundreds of services working together. So there is complexity, and but it's always easier to understand when we go step by step. So we'll look at those step-by-step approach to microservices, and then I will explain all of that is required for you to understand the entire microservices architecture and things like that. So so to get started, this is a very familiar page, .net.microsoft.com. If you haven't been here, you should go and check this out. Great place for all the resources that are out here. So this is one place that you need to focus on. Let's start here. So the microservices, go ahead and click on this one, the swim lane. And this is the page which talks about what are microservices? Why do you need microservices? And then we talk about microservices and containers. I mean, this is, I think, a common thing that everyone talks about, microservices and containers together, like Dockers and Kubernetes. Technically, they are, I mean, you don't need basically, you don't need Dockers and containers for building microservice architecture, because microservice architecture is just a, architectural style that talks about, composing your application into smaller services that are independently manageable, and most importantly, based on a focused team. Like, individual teams can manage their own services, and all these services, when you design it, you design with a business boundary or a bounded context using domain-driven designs and things like that. We'll go into that as well a little bit little later. So we talk about all these things, but I mean, if you're just getting started with microservices, I think the great place to kind of go hands-on is this section, which is called the Get Started. So we go into this. So every microservice requires an endpoint for the services to communicate with, right? So it could be a REST endpoint, a gRPC endpoint, or probably even into messaging endpoints and other things like that too. So just to get started with, we show you how you can start building microservice with .NET with a REST endpoint. So this is the tutorial here. It just takes 15 to 20 minutes. All that you need is go ahead and install the .NET SDK. And I'm sure you guys would know that .NET runs, it's cross-platform, runs on Windows, Linux, and Mac OS. So when you are logging in from Mac OS, your tab will be defaultly selected Mac OS. You can go ahead and install those bits correctly and then go ahead and create the service. It has .NET New Web API. We just create the name. By default, it gives you this weather forecast controller. We always talk about weather. And then it has this get method, which can generate some random JSON string with weather information, right? And then when you want to run it, you do .NET run, and then go to install Docker. And this is one thing that is additionally required for this tutorial because we're going to use Docker. So go ahead and install Docker. And then once you do that, add the Docker file to your project. And that's very, very simple things. I mean, there are many ways to do that. I mean, VS Code and Visual Studio has really nice tooling support, but we really wanted to, we didn't want you to have any kind of dependency on any kind of tooling. So this is completely, you can just start with a CLI and a notepad. So go ahead and create the image and then run the Docker images. That's it. So that will just make sure, make sure you enable Web API. You can also change it to gRPC if you want to see how that works with, creating microservices with gRPCs and things like that. And if you're very adventurous, go ahead and install this directly on Kubernetes, which is, we use AKS in this example. Again, we try to keep this very, very simple. If you really look at some of these microservices tutorials, they talk about Helm for deploying and other kind of things. But we make it really simple with using, if you go and look at this YAML file, it's YAML everywhere nowadays. So this is just a simple Kubernetes YAML where once you create this image, there is a step where you push it to a container registry. In this case, we use Docker Hub because it's free, and you would anyway use Docker login for downloading Docker. So you can go ahead and you install, push it to the Docker itself, and then use these YAMLs to pull that image back into your Kubernetes cluster. So everything is just CLI and just easy to get started. And we also have one small step about how do you scale your application. I mean, that's all about scaling nowadays, right? So just simple stuff to get started creating these endpoints. So Cecil, have you tried this?
Yeah, I have tried it. But before we talk about this, there's 2 points that you made that I think are really important that I want to dwell on for a little bit. Yep. And the first point that you made was that you don't need to be running Kubernetes or Docker or any of these fancy tools to start building microservice patterns and architectures into your solutions. You know what I mean? And I think for some reason, like, the industry has made us feel this way. You know what I mean? Like, and you don't really need to. Like, you don't need an orchestrator. You don't need to be using containers to start using the patterns. Now, obviously, as your applications grow and, you talk about going from 1 or 2 services to like hundreds of instances of services, then sure, then definitely something like an orchestrator would definitely come in and help with that scenario. But I think there's a lot of patterns that we're going to talk about today, but some others that, are also available that we could start building today inside of our applications today. And then we can have like the benefits of those things, without necessarily having to be like, oh my God, I have to rewrite my whole application to be a part of this world.
Yeah, exactly. Again, microservices, briefly talking about microservices, as you said, like, they are just architectural pattern, right? And there's a reason why you would go with this, especially if it's a complex project and you have multiple teams can manage independently individual services, then it makes sense to go with microservices pattern. And when you look at Kubernetes and Docker, they definitely solve a problem. And that is the reason why we go with that, something like that. Like Docker, your images are immutable. So you can create those images, you can ship different versions, you can have parallel ones running on Kubernetes and things. So when you understand these things, then it'll all make sense to have these things. But when you just say microservice, I mean, distributed computing have been there for a very long time, and all these patterns have evolved from that, right? So now with cloud, making use of every bit of the infrastructure that cloud provides and save cost, these are Kubernetes and Dockers and things really help. So yeah.
Right. And
So
then we do have
one
question really quick. We do have one question in the chat. We have a couple questions in the chat. I want to make sure we ask these before we lose context. And Andal Owl is asking, could you describe a use case for microservices? So I guess the question is like the typical pro and con. Like, when would I invest in a microservice architecture, and when would it be like too much? You know what I mean?
Yeah, so if you're a small company and you're doing file new project and you're able to maintain services with a small team, microservices may not be the right approach for you at all. If that is the case, start with monolith, and when your application starts to grow, you can slowly migrate to microservices. The typical use cases of microservices is like really large projects when you have multiple teams who have to ship things, like 100 times a day, 150 times a day, right? In such scenarios, these microservice architectures will make sense. I mean, I can't specifically say this particular use case would be the right thing or that, but again, it totally depends on your scenarios. And don't be bothered about so between microservice and monolithic architecture, right? Monolithic is not the old way of doing things, and microservice is not the new way of doing things. It's just an architectural style that you choose, right? Both has its plus and minuses. So weigh on that and decide on that, and be totally okay to go with monolithic applications. And one other thing I wanted to mention here is, if you're using Dockers and Kubernetes, you can very well use that with monolithic, style as well. You don't really have to worry about breaking things down into complex stuffs. And that is the problem, right? I mean, now when we talk about microservices and we put in like small projects and we try to put all the tooling around it and try to explain it, it becomes more complex. It looks very complex, but all this complexity exists for a reason. Like, if you have hundreds of services, your DevOps pipeline is set up for multiple teams to check in code and release to the things, then all these infrastructure and all these things will go transparent to you, and you will start focusing on your service and delivering value to your customers for your services. Then that's when it all makes sense.
Yeah, sure. I totally agree with you. And one of the ways I like to look at it as well is, like, you know when you need microservices when you start to look at, how do I scale? Like, how does scaling happen from a team perspective and also from a product perspective? You know what I mean? So, like, again, typical use case. I have a store, right? And now let's say, I'm expecting bursts of load to happen. You know what I mean? And I could either build more stores, right? Or I could just scale the part of the store that I think is going to be under the most stress. So that could be payment processing part of the store. That could be the inventory part of the store. You know what I mean? Like, I don't probably need multiple copies of the entire thing, but it might be helpful if I could scale like different parts of it independently. And so now, if we have things broken out into scalable pieces, you know what I mean? Using some of these microservice patterns, then that's when I think some of the benefits happen. And then now as well, like, we also have the ability to deploy differently. So our individual teams, if they're split up, we can now have each team can be on like a different deployment schedule, right? So now, like, I could deploy my payment processing section, or my inventory management section, or my fulfillment section, right? Like, assuming that they're all separate services with different teams responsible for the deployment and delivery of those things. Now I don't have to be like, oh man, like, Nish is taking a long time and I got to wait for him to finish the thing before I can deploy, right? Like, now we can be on our own schedule.
Yeah, it's interesting when you said that. I remember the time when we were in one of the projects. I mean, previously, not at Microsoft, before coming to Microsoft, at previous companies. Like, for example, like, if I have to ship my code, I have to depend on somebody else's. For example, for data, right? It could be simple table that I need to change for my service, but then I have to literally rely on see things. What are the things breaking, and then make sure that change is happening, and I do the entire test of the application before even I can ship this thing. So one key factor here when we talk about scalability and microservice architecture is you go with a single database per microservice. What it means is like it's not about relational tables, it's about database itself separate for the service. So you don't have, no two services can access somebody else's database or each other's databases, right? They always rely on the service endpoints to connect with. So that way, when I have to change something in my database, I really don't have to worry about breaking somebody else's code. And that makes it easy for shipping things faster. But that definitely brings in something like, oh, then the data is duplicated. Of course, it needs to be for these reasons, right?
Right.
So there are a few things like cap theorems and other things we can talk about. But then for today, I just want to keep it very simple and start with, something. So what I wanted to show here is like, someone who are looking for this kind of information, and this is very important. We have an entire guidance written, and that's what we see here as architecture guidance. Okay, so I can click on this, but this will go specifically to microservices. But I also want to touch upon the other books that we write. So this tab here, this is where I kind of live and breathe every day. So this is what I maintain. So there is a bunch of guidance out here, and these guidances are not built just like docs. It's basically, we work with customers understanding how a .NET taken into production. And then we learn from a lot of customers, and then we write these guidances. So this is architectural guidances. And here specifically, we have things for microservices, DevOps, modernizing, ASP.NET, right? So if you're building monolithic applications, you can look at this book, which is ASP.NET Core Architecture ebook, which covers clean architectures. And technically, this is very simple, monolithic design. And you can go and start with this. And there's eShop on web. There's a sample, reference sample. So this is another thing that we do. Every book has a reference sample as well. So it's not like just a guidance. It's also like how we did it. So we have this sample that you can go and try this out. And we also give importance to modernizing scenarios, right? Someone who is having ASP.NET web forms, right? Legacy applications. And now you are looking at, there is a new and modern way of writing UIs nowadays. So how do we go and do that, right? So we have a guidance on what are the strategies. I mean, yeah, you can't cover entire scenarios out there because people write apps in different ways. But what we do is from a strategic point of view, what are the things you need to consider? And those are added into the guidances. So there's this Blazor book. So if you're moving to Blazor, so we talked about gRPC. So WCF have been there for a very long time, and there are a lot of applications running on WCF. And now if you want to move to the modern gRPC, how would you do that, right? So we have the guidance for that itself, gRPC for WCF developers. And these are all current and relevant books. And one great thing about these guidances is that, they are free, and we don't ask any details. We don't need your email. We don't need your any other information, right? You just simply go and say download PDF, and it's just gonna go and download the PDF for you. There you go. So I have this nice little book that is current. Let me go back here. The other thing is, let me go back again one step. There you go.
Yeah, I love the fact that, kind of like what you mentioned, like I could just download the book. You know what I mean? It's not a give me your phone number and email and address and personal business. You know what I mean? I could just download the book, or I could just read it online too, because it's technically like a living document. And kind of like as you mentioned, it's it lives on a website. I believe they also are attached to repos, right? So folks could, if you like that docs experience, you can hit the edit button, and then you could suggest changes or update the document, or write new sections if you wanted to, or anything like that. So it's very accessible. Like this is technically open source guidance, right? Like they're all on GitHub.
Yeah, and they're part of the .NET Foundation as well. So, it's open source. You can contribute to it. And what we do for the PDFs is like, once in a while, we generate this PDF and we update the changelog, so you know what has changed. So we take community contributions. There are sometimes really small things like typos and other kind of things, but there are other times when someone suggests something really different, a different architectural style and other things, and we kind of evaluate that and update it. So talking about microservices today, I mean, this is the section where we have this Microservices Architecture ebook. It was written by Cesar a couple of years ago, and we maintain it, we update it. Recently, not recently, a couple of months back, we also wrote something called as Architecting Cloud Native .NET Apps for Azure. So we realized, once we wrote this popular book, which was focusing on architectural design patterns, where we talk about CQRS and Saga and other kind of things, cap theorems and a lot of things, domain-driven design, and how do you ensure that you do Dockers and containers in the right way, multi-stage builds and all those things. We realized there was an opportunity for us to explain people what Azure services to use when you decide to deploy this and make use of the cloud infrastructure. So there was AKS, there's Redis cache, there's sometimes you will have, how do I choose between relational databases versus maybe NoSQL, right? So those choices, how do I make that? And if I make a NoSQL choice, what are my available options in the cloud? So I get all of that thing in this book. So we wrote a companion guidance as well. And one thing we make sure when we write these guidances is that we don't really ask you to read the other book to come back to here. If there is an information that needs to be added in the same book, we add it to, because we understand these books can be read on an aeroplane with an offline mode. So we want to make sure we have enough content covered there.
That sounds good. And so Nish, I think we've been talking a lot about how to get started, right? Like we have guidance, we have tons of these ebooks that are available. We have those videos as well, tons of videos on Channel 9 and whatnot that we can watch. I really want to see some code now. Like I want to see some code. I want to see like, what does it actually feel like to build one of these things, like in VS or VS Code or or something like that?
Yeah, absolutely. So let's go ahead. I'm on the same page. If you just go down, you will see something called as eShop and containers, right? As I mentioned, all our books come with reference samples. So we're going to look at this one right now. So let's go to this page. There's a vulnerability that I need to fix. We'll go ahead and do that later. So this is the microservices reference sample, which is eShop and container. You can see the popularity, like everyone refers to this, 61.1K stars. And this is a great sample technically. So we do this as a shopping sample, because I know every time you look at microservices examples, everyone talks about shopping. And the reason for that, it's not shopping being the perfect use case for it. It's just that it's easier and relatable when you try and understand the code. But it can be applied to any business domain. It doesn't have to be just retail, right? We have customers who are using from healthcare and other things, right? So this is eShop and containers. So if you want to get started with microservices, just go ahead and clone this repo, and I'll show you how to run this application as well, right? Just clone this repo in your folder. And before I get to that, let me just quickly show you this reference architecture, because this is important for those of you who are looking for really advanced implementation for microservices. Now, eShop as a sample is really simple, but the implementation of it, when you look at it, it is really complex. And again, as I mentioned, the complexity exists because we're splitting all the services into independent, smaller apps, right? So look at this here. So identity, catalog, ordering, which is all very relevant services on the e-commerce platform. Every single service has its own database. So for example, identity uses SQL Server, catalog uses SQL Server, but the moment you go to Basket, it has a Redis cache. You use marketing, that has a Cosmos DB, and so on, right? And every service that works with each other, they're not always on a synchronous service-to-service communication, but they're also on the async messaging patterns, like we use RabbitMQ or in productions Azure Service Bus. So we have this entire architecture out there, right? So let me not again spend a lot of time showing this thing, but I mean, it was important to just explain that before I get to this code, because the moment I start the code and it's like, oh, this is really complex. Actually not, because they're just microservices, right? Nice. So once you clone this repo, you just have to do Docker compose build and Docker compose up. That's it. So let me open the PowerShell. So
while you're doing that, so you're telling me, because I've heard about this eShop thing before, and I've heard how complex it is. Yeah. Everyone is like, eShop has all of these services and all this stuff happening. and this is a non-trivial application. You know what I mean? It's not Amazon, but it's a non-trivial application. And so you're telling me the only thing I need to do, I mean, assuming I have .NET and Docker on my machine, the only thing I need to do is say Docker compose up, and it runs.
That's it. Just download this thing. And I know where people get into issues, and I can talk about that too. It's about Docker installation, right? Sometimes if your Docker installation is not done correctly, configured correctly, you may run into issues. But Docker with WSL, so if I go to the settings, right? Let me show you this as well. So with WSL setting, once you enable this, and if you're on Windows 10, you're done. Like, there's nothing that you need to worry about. But if you're not on WSL, then you need to go and configure your VM to have at least a 4 gig of RAM for all these things to run, because there are like a few of microservices that's running and taking the resource. But when you're running on WSL, it takes the entire machine's resources, so you won't see the difference technically, right? So as long as you do that, you're good. And all that I'm going to do is, I have already built this. So usually build takes a little bit of time, but otherwise I just do Docker compose. Did I make a spelling mistake? Not now.
No, do it later. All right. And so you're in the right directory, I'm guessing, right?
Yeah. Here you go. So I should be inside the source folder. So let me just quickly show the source as well. So while I do that, Docker compose.
Right. And so then for people that are not familiar too, like when you do Docker compose up, what it's doing is just starting all the services that are needed to get this thing running, right? So like the web APIs, the databases, the messaging things, like if you're using Redis and all of these different things, it'll just start them.
Exactly.
You know what I mean?
So if you go into this directory, right, we have this Docker compose, for example, YAML file. Right now, this is going to be big. So this is where we define, like, what is the service that we use and what are the configuration that it needs and that kind of things. So once you define this, when you do Docker compose up, it knows to pull its images and then run it. So that's all it takes. So once we do that, like, let's go to the web status. So we also do this, and it's very important for microservices to use something like this. So we use .NET's health check system to check what are the services that we are working on and what our individual services are working on. It depends on is also working. For example, basket depends on a Redis. So we're going to make a health check to if Redis is working. That means the entire service is up and running. So we have all these things healthy. You can see that everything is running fine. So once we have this running, let me go back. I can use either an MVC or a SPA. It's just that, just to show you the sample differences, we just built 2 web clients. But choice is yours. We can also build on Blazor if you want to, but right now one is on MVC, the other is on SPA. So so there you go. It's all up, right? All the services have come together. I can go ahead and hit login. Oh, this is world's most advanced e-commerce application. So we give you the username and password. You don't have to register.
Oh, nice. That's convenient.
Yeah. So you can see the number of services that's, working behind the scenes when we do this. Add to cart. So it has some really simple stuff, like if you want to filter by .NET, t-shirts and other things. And by the way, these are not real apps. Okay, don't add to all these carts and just say, oh, my hoodie didn't come to my store.
You mean I can't get a .NET hoodie from eShops and Containers Web?
Not from here, I think. I think .NET Foundation has a store, by the way.
Oh, that's right. They do.
Yeah. You can ship it from, but yeah. So I'm going to place an order. Oh, the card is expired, so I'm just going to fix my cards real quick.
Oh, nice. You have credit card validation too? I love it.
Yes. Place order, and that's it. So you can see all the signal are functioning. We get the notifications live. So whenever these things change. So now the thing is, we never integrated payment gateway, so we just mock it.
Sure.
And a few other things. Yeah. So what exactly happens behind the scenes is like a bunch of services coming together to make this happen. So if you look at inside the services folder, I have basket, catalog, identity. So each of it is its own service, and each of it depends on its own database. So we don't have a single database pointing everything at one place. It's all different databases, right? So,
and are each of those a separate .NET project? I'm guessing like each of those is like a separate web API or web UI project.
Exactly. It's a separate web API REST. I mean, this one is gRPC. We have internal communications, everything on gRPC now. Some of the things which we are exposing outside is on REST, but otherwise, most of the internal communications and other things are on gRPC. So, as I said, we update it like as and when gRPC become mature, and we have the .NET stuff for it. We just update all those things for in this application. So this is like for us, it's like a production app. So we keep maintaining this in that fashion.
You gotta keep it up. Got it.
Yeah. So the one anti-pattern that we do, I'm sure a lot of you would say, hey, I know this is microservices, but guess what? You're actually running everything inside a single repo, which shouldn't be the case. In microservices, even the repo has to be separated so that you don't have any dependencies. But because it's a reference sample and we want you to get started quickly, just like Docker Compose up, we just made it into mono repo. But one intelligent thing that we did is our CI/CD pipeline is different. So we have different pipelines. So when you commit code inside the basket folder, it's only the basket one that gets built and pushed into the Docker Hub. So next time when you pull from Kubernetes, it's the new one, right? But none of the other ones are others are affected. So we do this kind of intelligent magics out here using the Azure DevOps trigger syntax there.
Got it.
Okay.
I like this. And so now for me, like, let's say I am very unfamiliar with like this whole microservice thing.
Yeah.
Thing patterns and stuff like that. So I could start looking through this code and look at this as like just like some inspiration, right? Like how can I possibly structure, on disk like my projects? You know what I mean? And like how can I like put them in containers, and how can I have different services running, and all of these types of things. And now I can kind of pick and choose some of the things that you're using in this, fairly substantial demo. You know what I mean? To be able to show folks how this actually works.
Yeah. So again, we want to be very clear on this. Like, this is a reference sample, but it's no way it's how Amazon has built this, right? So it's not.
So I can't run my coconut water store on this.
You could. I mean, I'm just saying that it's not something like, hey, I've noticed this one thing. People say, okay, Microsoft has told us to do it this way, and that's the right way to do it. Well, it is right for certain scenarios, but depending on your scenarios, you feel free to just change and modify. All these patterns exist for a reason, that you all are on the same page, you build in the same fashion, you do things quickly. So if there is anything that needs to be broken for your scenarios, feel free to do that, right? And that's why we kind of like put a disclaimer here saying, important things. This is always beta. We keep trying things. We have branches for new stuffs. So things can be broken sometimes. But we're very sure we fix things very fast. I mean, we kind of like do this almost every day. The other thing that I wanted to show you is this wiki. So the book actually talks about a lot of things related to the architecture guidance and other kind of things. But this wiki actually talks about a few more interesting things like, hey, how did we do logging? So we use Serilog. We also use Sec for the logging. We talk about like if you want to go production with maybe Azure containers and other things like that, Azure monitors. You can actually do that too. So we talk about those things. How did we do health check? And for today's topic, one of the things that we can stick to is resiliency. And we're talking about cloud apps, and cloud in any services that is out on the internet can fail. I mean, that's how we need to program things, right? Failures do happen, partial failures exist, transient failures. So especially in case of Kubernetes and other things, maybe Kubernetes is kind of like killing the pods, bringing up the new pods. So how does, when you have like hundreds of services, and if a service A calls service B and the B calls C, and C fails, the B and A also will fail, right? So you'll have cascading failures. So how do we stop that? How do we handle this failures gracefully, right? So we use two things. One, we can use it with the code using Poly, and the other using service mesh. And for today's demo, I want to show both of this.
Nice.
Yeah, and I don't want to do that in eShop and containers because definitely we will lose track and we will go on different stuffs.
Yeah,
so
we will try to in there.
Yeah, so we will try to do this in a simple weather demo. Cecil, do
So
you
while you
want
go
to
ahead
pick
and you
any questions?
switch, like I'm gonna just pop in the chat and see what's going on with folks.
Sure.
See if we have any questions or anything people are asking. All right, so here's an interesting question. This person is asking, I'll put this up on the screen really quick. For an e-commerce site, a microservice is the right approach, but not many people or companies run e-commerce sites. Therefore, clean architecture is enough, question mark. So I guess they're asking, like, I guess the question is kind of like, do I have to run a microservice for an e-commerce site, or can I just build it using a clean architecture pattern?
Yeah, I mean, clean architecture is a great start. Again, when you talk about microservices, you have to think about scale. You have to think about how many number of teams. I mean, microservices is very integrated with DevOps culture as well. Like, how many teams like are we talking about? Are we talking about 2 teams? Then I don't think you need microservices. You probably can just work around without that. And at the moment you split database, there is so much of other things that happens, like making sure all the services are available, making sure the data is consistent. So there are a lot of other things that you need to pay attention to. So do you have that kind of team strength to run this? Then yes. So it technically, the choice for microservices versus monolith is not about choosing on business domains. It's not about choosing, oh yeah, if it's e-commerce, let's do this, or if it's banking, something else. No, it's about how's your team composed of, right? Can you all about independently deploying, like can 2 people independently deploy without breaking things? That's the most important aspect that you need to answer before you go into this.
Got it. And then here's another question coming in from YouTube as well. And this person is asking, when you say different database for each service, how do you share data between services? Like order service needs to know about payments. Like, would you have to query 2 different databases?
Yeah, so always services have to, this is a great question, by the way. Always services have to work with their endpoints, not with their databases. So you will, for example, in this case, the order will never query the payments database. The payments will never query the orders database. So when an order is placed, it needs to be notified. So you can create domain events, integration events, and other things. So that could be something which a simple, async message sent to the PubSub pattern, basically publish an event that has happened in your service. So the payment can listen to that and then react to what it needs to be done. For example, I'm sure you would have seen this when you are shopping on Amazon. You just go and submit the order. And then they say, okay, thank you for order, and we'll get back to you something. And later, the payments would have failed, and they say, oh, can you retry this? We can get through, right? So those all things happen because individual services are working in the backend. So no 2 services working together. You just let the other service know what is your event, and the other service can actually figure what it needs to do. So that logic is within that service, and no 2 services know what other services do, by the way. So you are completely independent.
Got it. And then this next question is kind of leading into the topic that you just mentioned about service meshes. And they're asking, well, what's the criteria to use a service mesh? Like, how big does the application need to be?
Yeah, so service mesh brings in a really nice features. Like, if you're running on, by the way, if you're running on Kubernetes, I think it's a good idea to go with service mesh because if you have multiple microservices working with each other, service to service communication happening, you need observability. You need to know what service is breaking, how do you handle that kind of thing. So you need that kind of dashboards and all those things. So service mesh brings in all those things, and also the resilience part, which is what we're going to look at it in a bit. So we'll talk about that. So it's not about how big the application, it's about, do you need these features? Do I want to have observability on the thing? Like you can rely on some of the things that the cloud providers give you. If you're happy with that, you don't have to go to service mesh. But if you want that extra information to do like resiliency and things like that, then yeah, you can go with service mesh.
Cool. All right, Nish. All right, I'll let you go ahead, man. We have some more questions coming in, but let's get to the demo and then we'll get back to.
Right. So let's go to my VS Code. Okay, so this is a simple application. So I want to keep it very, very simple. Again, if you feel that, hey, this is too much for this, just understand we're talking about simple service. But when you talk about complex and scalability, then you can put these things in perspective. So something fell off.
Okay. You broke it, you bought it, man.
I don't know. Yeah. Cool. So it's late in the night, and I'm a little scared now when something falls off.
You might have ghosts walking around in your apartment.
Yeah. So there you go. So I have the backend and frontend. So in this backend, if you look at, this is the same weather forecast controller that comes by default, as we showed you in the initial starting place where when we did the get started one. So this is the same sample. It just creates a random thing. So what it did is I went ahead and just removed this random thing because I wanted to bring in my own data store into it. So I use something like a Redis cache, and then I generate these random values, but I cache it in my Redis cache. So for 5 seconds, so every 5 seconds, this data gets invalidated. The cache gets invalidated, and then the new data is created, right? And to bring in to talk about partial failures, this is something which you shouldn't do in production, and this is just my own logic of breaking things. So whenever something goes wrong, so some random value, I'm going to throw an exception, trying to show that, okay, for sometimes there will be system down. So how do you handle it? Figure things out, right? So let's go and look at that. So this is the weather forecast controller. So every time you make a call, sometimes it can fail. Okay, that's the backend, and the front end basically has a simple UI, and then it has this weather client, which is going to make the call to the forecast API that we just created on that other backend service. And then every time it makes a call, it may have failures. So let's see, how do we handle those failures in front end app? So before that, let's get started with running the sample, right? So for this demo, I'm going to use Ty. So if you haven't started to use Ty, you should do it. If you have more than one service that you're working with, which I'm sure in your cases it would be, start with Ty, because Ty is great. So I have this Ty YAML. You can see that I'm actually bringing in the backend and front end as my services. And because I want to store the cache, so I'm using Redis, and that's an image, which is great. I'm not even installing Redis on my system. It's just an image. And also because Ty gives some nice extensions to do distributed tracing, like kind of like find out what applications are working with each other, how much time it is taking between each other. I'm also using an extension called Zipkin. So all that I need to do is I can just say Ty run, and it's going to. So in the real world, like if you're not using Ty, if you may go into the backend folder and say .NET run, and that'll open up on a port that you configured, and then you go to the front end, and then you do .NET run, then you'll have the front end port and things like that, right? In this, when you use Ty, you don't have to do any of those things. You just say Ty run, it ties things together. And I'm going to have another attribute here, which is the watch. Basically, I'm going to make some code changes, and I don't want to do the Ty runs again and again. So what this does is basically it gives you this nice dashboard. So Cloud Native Apps is all about dashboards. Let me see which browser opened. Yeah, there you go. So this is my applications. You can see that I'm running backend, I'm running front end, I have the Redis cache, I have the Zipkin all running, and there is also this is another nice thing that Ty does, right? It just picks up the port that is available on your system and then randomly assigns it. You just have to configure it correctly to read that from the Redis configuration. Sorry, the Ty configuration. So if I just go into the front end, there you go. We just hit with an error. Now, if I just go and refresh, it works, right? So each time I refresh, there is an interim failures, right? That can happen. And this is pretty much that happens in cloud. And this is what we need to handle. Now, whenever this exception happens, I mean, imagine if you are on the e-commerce site and you went into the order, you went to the payment, and the payment failed, right? And then you just throw some error like this, and user will be very, very upset about this, right? So how do we gracefully handle this kind of thing? So let's go and fix that, right? The simple thing, whenever you make a service call from one service to another, if something fails, the basic thing that you need to do is do a retry. And there are multiple ways you can do it. So in my case, what I'm going to do is I'm going to use a project called Poly, which gives this nice implementation for retries. To add that, all that you need to do is add a NuGet package called Microsoft Extensions HTTP Poly. That's it. Once you add that, you can go into this. I mean, in my case, I have it in the startup.cs. I have this add HTTP client. You can see this is what configuration for Ty. So whenever I say backend, it gives me that port directly. If I'm not using Ty, I'm just going to fall back into the Finance01, which is a hard-coded port in the backend. So we'll ignore this for now. The next thing I'm going to do is I want to retry, right? So in a Poly library gives this nice extension method called add policy handler to your HTTP client. So I'm going to uncomment this code, remove this unnecessary semicolon. And I have this local methods get retry policy. Let's go into that. So there you go. So what this does is I'm using something like wait and retry async, right? So I'm configuring if something wrong happens when a service connects to another service, I'm going to retry for 5 times. And then, but then, you shouldn't retry very often because then you can get denial of service and other things, right? So to avoid that, I'm also doing an exponential backoff, which is like just writing my own logic to exponentially, make the try. And you can also add jitter logics and that kind of things, whatever it takes to keep the server not choked, right? So that's it. So I do wait and retry. And the other policy that I'm also adding is the circuit breaker. And this is also very interesting. So circuit breaker is very simple, right? By default, the circuit will be closed. That means whenever you make a call, it is going to directly make a call to the server. But after, let's say, 15 retries, the server is still failing. In such a case, what the circuit breaker does is it keeps the circuit open, so it does not make calls to the server anymore. So whenever there's a HTTP client dot get async, in this case, it is going to say the circuit is open. So that means it's not even connecting. So you can, as a business scenario, you can decide what you want to do in that scenarios. So it's simple policies that we are creating here, and we're also saying like how much delay you want between, for this the circuit to be back closed.
Okay, and that makes sense.
Policy.
And I know a few folks have been asking about like the differences between just retrying and circuit breaking. And I think with retrying, you actually make the call to the thing. Yeah. You know what I mean? Like to the resource or the API or to the server, the remote server, whatever you're reaching out to. But with the circuit breaker, like there's no communication at all. It just stops it for some fixed period of time until, it makes sense again to like reopen or to close that circuit again so that we can start making communications.
Absolutely. So now if I go back to my code and just refresh it here, there you go. I can go and, this is the mistake that I always do. I don't do save. So I just went ahead and saved. So while I do that, what happens is the tie, because I'm using watch, it is going to watch my changes and it is going to go rebuild the stuff for me. Did I do the tie run watch? Oh yeah, I did.
Yeah, you did tie run watch.
Okay, so let's go back and just refresh this. Okay, what happened? What happened there? Refresh this. Oh yeah. Oh damn. So that was the retry that was happening behind the scenes. So I'm going to refresh this. Okay, there you see this progress bar. It's just spinning, but then when it comes back with the result. Okay, let's do this again. It's very difficult to reproduce these things, but it's so important to keep it. So now it's refreshing. Oh my God, it's all working. Well, let me show you with the logs. So if you go into the front end, for example, the logs of the front end, you can see that at some point something would have broken, some exception. There you go. These are exceptions, and there will be logic for retrying too. Okay, there you go. So whenever there is exception, there's retrying in 1.5 seconds. There was retrying in 2.25 seconds, and then when it is successful, it just goes and comes back with the result, right? So all these interim failures can be handled now within the code, which is very straightforward, right? Simple code. Now, okay. here's we'll take another approach for this now, for implementing the same concept but in an infrastructure, not in the code. So think about this, like, many times you will have services that are working, maybe a .NET service is working with a Java service or a Go service or something else, right? And for everything, if you had to bake everything into the code, you have to write the same logic in different languages and maintain it. And that's going to be hard. So wouldn't it be nice to have that written in some sort of infrastructure layer and not in the code? And you can just get rid of all these kind of codes from your services. So your service is focusing on your business and business functionalities and not focused on the infrastructure, right? So we can implement the same thing in a service mesh, okay? So let's go and try that. So I'm going to use something like a Linkerd, but you can use any other service mesh like Istio, Console, and things. I'm going to stop this.
And so, Nish, really quick, because I know some folks may or may not know about this. What exactly is the purpose of a service mesh? Like what is it? Like, what do we use it for?
Yeah, so service mesh most importantly gives you couple of things. One is observability, like understand how the services are performing with each other, like, and they're connecting in a cluster. It gives you reliability. For example, when you just resilience, right? If you want to have these retries and other things configured, it can be configured separately outside your application. So when I say that, how does that it do? Basically, it implements something called a sidecar pattern. So there is your pod, which is your service, which is running, and there's another pod that will be placed along with it, which will handle all the network traffic for you. So all the traffic is basically routed between the services, between these proxies. It is not your code that is handling it, right? So because there are proxies existing, there's all the cross-cutting concerns can be handled. One important aspect is if you want to have mutual TLS implemented between services, you can implement that in the service mesh, right? There are many things that you can do with the help of service meshes, especially in terms of reliabilities and other things. And it also gives you some nice dashboards to really monitor these services, right? So again, think about this. Like, it's not about two services. You're talking about like 50s and hundreds and thousands of services that are running in the cluster, right? So to manage these things between these things, we'll see that in a bit, like what it brings in, right? So
because as you're talking about, like, I'm hearing it's like a proxy. You know what I mean? Like, I go through the service mesh to communicate, but then I'm guessing every service has its own copy of the proxy, and now it'll just, they're coordinates together where things are supposed to go, right?
Exactly. They know to work with each other. Okay, let's look at this. It's easier to explain this in using the code sample. Okay, so what I did is, by the way, I have this running on my Kubernetes local. Again, I'm using the Kubernetes that came with Docker. It's just much easier. You can use Minikube or you can use Kind, whatever works for you. Just feel free to use that. So if you look at this, it's all the same samples, like backend, frontend, Redis, and Zipkin that we showed earlier. And the only difference is it doesn't have the poly code. So I did not bake in the poly code because it is unnecessary. We can do this in infrastructure. So the way I installed it to Kubernetes is because it's by tie. So if you use tie deploy I, which is interactive, you can go ahead and deploy it to the Kubernetes that is configured locally, right? So I did that. Once I did that, I enabled service mesh on that. So if you want to see how this code and things, we can go into that, but let's look at the sample first. So to see how this is all meshed, I'm going to use the Kubernetes, Linkerd dashboard. So many dashboards, as I said. Okay, where is my dashboard again? It's I'm lost in the browser. Let me see. Wait, what? Go back. Oh, right. Oh, really? Okay, there's a background job running, so let me just find the port for the Linkerd dashboard. Just give me 1 minute to check what the port it's running on.
No worries. And as you do that, I'll look through chat really quick and see what folks are asking. I think we have a lot of questions here that are coming in from Twitch. Let's see what our friends in Twitch are doing. Here's an interesting question that someone's asking that we could probably address super quick. And just Romagod is asking, is microservice in .NET another name for a single project? So pretty much like a single ASP.NET project or a single project. And I know for the demo, you've been showing, or we generally show single projects as like, this is the microservice, but it doesn't necessarily have to be, right? Like a microservice is not about like the physical size of the service, right? More so we'd say it's more about the separation of concerns, you know what I mean? And what's responsible for what. Like, would you agree with that, Nish?
Yeah, absolutely. I mean, microservice is just an architectural design pattern. It is not about, it's technically not about how big or small. It's not about, individual services or something like that. It's basically about splitting those services into independent deployable units, right? I hope I explained that, right? It's very difficult to explain. I mean, if you ask me, like if you start with an ASP.NET Web API project, is it going to be a microservice? Yeah, it's a great start for a microservice, but it will make sense when you have more services, and then how you define your bounded context between them, and that's when you can actually say this is the application that follows the microservices architecture pattern.
Yeah. And then we also have someone that's asking for the link into the code to the one that you're doing right now.
Oh, this one? Yeah, I can share that with you. It's there on my GitHub repo. I'll just make it public and share that later.
Okay, great. And then one more question too. So someone is asking, can we use retry policies with gRPC?
Yeah, absolutely. Sorry, I was just executing this.
Because the poly package is an HTTP package, right? So if you do retry policies, you probably have to do it yourself.
No. So poly itself has these. You can have policy dot, and you can pretty much put anything in that method.
Yeah.
You may not be able to use the HTTP extension. I'm not very sure how that is done in gRPC, but you can definitely use poly's, delegate to have anything inside the delegate can be retried, wait and retry, and all those kind of things can be done. So you can use the poly package to do that. Yeah.
All right,
I'm trying to see the port. Do you know what port this thing runs on? I'm just trying to, because I know pretty much. I'm just trying to figure where.
You want the port for Linkerd?
Yeah, by default, what is it running on? Because I
think it is 330. No, that's not it.
I think it's in 5000, 5070, something like that. Let me see. Host 50. Oh yeah, 5070. There you go. So this is what happens. This is a good learning for me.
Okay.
Sometimes, so if you run it and leave it, your port is occupied, and just better remember it's 50750. Sorry. So that's the port it was running. Okay, let's get back to what we're doing. So you can see that this is the meshed, and I'm actually deploying all my backend, front, and everything inside the default namespace, but you can just be specific on what namespaces you want to. So you can see that this is the mesh, that it's all meshed right now. So let me quickly show you how to install Linkerd. So here's the code. So if you go and download the Linkerd CLI from the Linkerd's GitHub release GitHub project, and then just go ahead and add it to your path, and then just run this Linkerd check pre. So make sure your kubectl is configured to the local Kubernetes cluster. Once you do this pre-check, I mean, it can be on AKS, it can be on any other cloud provider as well. So once you do that pre-check, you should be good to go. Everything, if there's something has to go wrong, it will just tell you there. And then you just apply the configuration, and this will go ahead and install Linkerd into your cluster. Once you do that, there's another command that I use to mesh it. So you can, again, this is an opt-in, right? Not every service need to be meshed. You can keep some services out of the mesh too. So if you want to opt into this, so here's a little dev thing that I did. Let me just quickly grab that and explain this. So this is the command that I used. So because I used thai deploy -i, I did not write those YAML files that initially I showed when we started with getting started with microservices. Since I did thai deploy, it's all transparent. Sorry, it's kind of abstracted away from me, so I don't even have to bother about those YAML file. So what I did is I kind of got the deployment, whatever YAML file was created, and I piped into this Linkerd inject command. What this does is it'll take that YAML file, it'll add annotations for Linkerd, and then it will then reapply into my cluster. So when this happens, that's when your service will just get added to the mesh, right? So now to see this in action, let's port forward this. Parts. So right now we have backend and frontend. So let's do the frontend.
And while you're doing that, we have another question too. So the question is, for some reason, some of these things are getting blocked by the bot for some reason. But anyway, Samuel is asking, can you use something like the actor pattern, like akka.net or Project Orleans, when you're building microservices?
Yeah, absolutely. Yeah, Project Orleans is great. You can use that, akka.net, yeah, whatever. So we are also doing eShop on Dapper. And in Dapper also there is actor model that you can use.
Nice.
So yeah, you can use that too.
Cool.
Okay, so service, and then I'll just use frontend, and let's port it to 5,000. Internal port 80. Now I can go to my local host and 5,000. And now, so this is running inside my Kubernetes. So I'm going to refresh this. There you go. So we have this error. So this is because in the production environment, we get this different error message. So if I refresh this, there are errors. So if I go back to Linkerd dashboard, and you can see it says 100% success rate, which is untrue. Let's do one thing. Let's go ahead and kind of like bombard the front end with some more requests. So for that, what I'm doing is I'm actually writing a PowerShell, which is a while loop, and I want to hit this URL. Let's do this. I'm going to hit the local host 5,000 and for every 1 second. So let's see what happens now. Right, there you go. The success rate reduced. So do you see this with Service Mesh, with this dashboard? You have a good observability of how your services are working with each other. So think of it with hundreds of services. You will have a better view of this. And it also comes with this Grafana dashboard, which is very cool. So it tells you about the latency. It tells you about the success rate, the request rate of all the traffics, right? Whatever comes to the service,
Oh, that's
whatever
cool.
goes. So yeah, this is right.
Yeah,
now
I didn't know
this
that. That's been interesting. Oh.
Yeah. So it all comes. I mean, this is all free, right? With just enabling Linkerd. So now if I go into the backend, go to the default, and go to the backend. And now you can see even in this dashboard, you will have this live calls here. So it tells you where the request is coming from, how much is the count, how many times what's the best case scenario, right? What's the worst case scenario, and the success rate. You can see that, we have just 40% success rate now. So now let's go ahead and implement something called the retry logic, right? So instead of we going and writing anything in the code, we can go into this YAML file. So in Linkerd, anything that you want to define as a service and you want to provide extra information, you write it inside the service profile. Okay. So here we have the weather forecast. That's the path. Again, I extracted this out. Use a simple command to understand how this was deployed, and then I extracted this out. And the rest of the things that I'm going to configure here is just is retriable equals true. This is all it needs, right? The moment you set this, it is going to retry every time there is an interim failure. And this uses a different retry system, which is using budget, which is like, it says, and I can take another 20% of the total traffic as a retry mechanism, right? So that's the thing. Again, you can define this even in Poly with an advanced circuit breaker configuration. So it's just in case of service profile, it's just very straightforward, just writing these things down, right? So that's all I did. And then now I can just go back and to my code, and I need to redeploy this. Oops, okay. Am I? Okay, all of these are. Go to the folder where, let's do that here. CD service mesh, and I need to apply this. So I'm going to use kubectl. Let me see if I have the command written already, then I can just do that. Yeah, there you go. Backend profile. I apply this. And now if I go back to my...
you can go back to the dashboard.
Dashboard. Yeah, dashboard was going to say the same thing because your service is anyway failing. But you can see that now I'll never get that error that we saw. Because in behind the scenes, it's the retry has been taken care of.
Cool.
There you go.
Cool.
So I'll refresh. So I can go back to the dashboard. I can show you that it will still show some failures. But see that success rate is 87. So you'll see the failure still, but then it's handled well.
Nice. Now, I'm back in the chat and I'm just kind of looking and seeing what folks are talking about. And the biggest question so far always seems to have to do with databases, which kind of makes sense, right?
Yeah.
People want to know, for instance, here's one question that came in from Twitch, and it's saying, hey, if I need to synchronize the different microservice databases with a big central database, I'm guessing folks might want to do data warehousing or some type of ETL type work, right? Like what is the best option for that? And I know we have some options in Azure, right, that we could point folks to.
So let me just read this again. If we need to synchronize the different microservice databases with a big or central database. Okay, I'm just trying to understand, synchronize different microservices. Why would you want to do that? Because you don't need to do that, right? Because
I'm guessing folks might want to do reporting, right? I'm guessing if you have like multiple databases and you wanted to report, like I'm guessing talk about sync out and not sync in. You know what I mean? If that makes sense.
It's the cold storage versus the hot.
Or something like that.
Yeah. In such cases, you have background services or some sort of other services to pull in the data and then move it, like create that service separately and then sync the data. Write your own synchronous logic to maintain those things. The other option also you could do is every time there is a change, you can actually send and create an integration event for some background service to wake up and then push it to the archival systems, and then just maintain those synchronous sync between the databases. That could be one option. Yeah.
Okay. And then here's one more database question that's coming in from YouTube. This person's asking, if my data is divided between different services, how do I query data that's in multiple databases?
Yeah, this is a very good question, and I think this is where we need to go a little more with the pattern. I mean, simple thing is like search, right? So you will have orders, you will have payments, you will have catalogs and other things, but your order will have a data of catalog, and then it'll have the shipping address. They may be technically different microservices relying on different different databases. And that's why you implement something like a CQRS, command query responsibility segregation pattern. And you can have this data as a materialized view and then store it separately in the search table. And you may be thinking, wait, what? So yes, the duplication of data, and that needs to exist, because a couple of things you can do. Yes, you can have an aggregator and query this. Like, for example, in a mobile client, when a request is made at the API gateway in mobile client, what happens is your query comes from multiple places, right? So you will have basket, you'll have other things, but the real estate is really small. For that alone, we have this mobile backend for front end, which will actually query multiple services against service endpoint, not database. You're not hitting the database directly. You're hitting the service endpoints, querying the data, collating it, and then sending it back. One way is doing that. The second is, as I said, CQRS is a great way where you build the query from multiple databases and then store it in your local database. Like when I say local, I meant like if your search service should have those basic implementation. And when the user wants to know further, then they go drill down the data. Then you go query that particular microservice and get the relevant data back. So that's the right way to do it. And when you say duplication of data, I'm not saying duplicate entire data. I'm saying duplicate the relevant data that is needed for that service to show up.
Got it. That makes sense. Mm-hmm. All right. So I know we're running a little low on time.
Okay.
We're definitely over a little bit. But
great.
Let me let you finish the demo, and then we could close really quick.
We're done. I think we can actually show folks where they can get started with hands-on with microservices. I know there's a lot of questions. The book answers a lot. The reference sample answers a lot of your questions, but there is also something called as Microsoft Learn, which is like a hands-on tutorial. You should all try this. ASP.NET if you go to aka.ms/ASP.NET-microservices, this is something which we are building right now. It's all about building microservices, but directly inside the Azure CLI, right? So just start with this one: create and deploy a cloud-native ASP.NET Core microservice. So we go into this, and these are the modules that gets covered in this. If you go into this start, let me quickly show you. So when you copy this particular command and put it directly inside the Azure CLI, we set up the entire eShop on containers into the AKS. So all you need is an Azure free account, like create an Azure free account if you don't have one, and then open the Azure CLI. But there's enough instructions here, so I'm not going to spend time on that. And then just copy this. So we will set up the entire eShop on containers for you. And once you do that, your job, as how you do in microservices world, is you don't look at this big architecture. You look at, okay, your job is to build a coupon service to this, right? So you go and implement a web API. You implement, your coupon is going to be stored in a MongoDB. So you kind of like write those, data connectors and other things. You build this microservice, and then you will learn how you can package this into Docker images, ACR, and then finally deploy using Helm into the Kubernetes. And now you can see the real benefit of how exactly it is done in real world, because you don't look at the big picture. You look at your service and you kind of deploy it in real time. And you don't break anything when you do that. The new services come in, you go to the API gateway and configure this new route. Here's a new service, and then the other services would know how to talk to you. So that's what you're going to implement and build. Do that, and then there are other ones. We talked about resiliency, so the same hands-on can be done on this module as well. We do both poly implementation as well as Linkerd service mesh. And here you would be directly doing it on AKS, not on your local. And the good thing is you can run this on iPad. You really don't need any kind of infrastructure or local dev setup. And I wish I had more time to show you all those things, but I think it's just self-explanatory. You can just go and click, and it'll give you all the instructions to go from there.
Yeah, I think just in terms of takeaways from today, I think we can see that there's definitely a lot of resources that folks could go to talk about and get into microservices. I think one of our goals was today to kind of just give folks an introductory view into like, where can I go to get started? Like, what are some of the things that are possible? We saw a big demo with like the eShop on containers, which is like the mega demo is what I like to call it. And then now we saw a smaller one, and you're going to share the link to that sometime later. But we saw a smaller one that you created that uses Project Tie and is not as complicated, but still uses the same patterns. And I think that's great because it still enforces what we were saying earlier. You don't have to have a massive application to start using some of these patterns. Like we talked about using resiliency. We talked about using things like service meshes and those types of things. We didn't talk about it, but like there's also service discovery and centralized configuration and like all these different things that kind of came out of the space. But again, we could use them today in, non-monolithic, applications, or we can use it inside of our monolithic applications, all depending on whatever makes sense for what we're trying to do.
Sure. I think we have more questions.
Yeah, do we have any more questions? Is anything anyone want to ask? Let's see. This person is asking, can you give a keyword on any techniques for me to explore for this question? Again? What is this question? Let's see.
Keyword? There's one question before that. Can you guys do the design patterns for microservice starting from scratch, please? Yeah. So Cecil, why don't we can do that, right?
Yeah, we could do that. Yeah, we could talk about that.
Yeah.
We could do that. What else we have going on in here? How can we handle data concurrency if we need to insert from more than one microservice?
Yeah. So that's the saga. And I think I would so this is all written in our documentation. I would, instead of me explaining this right now, Saga, event sourcing, and all those things are there. Go to the .net/architecture. Get to the eShop on containers. Microservices book. Refer. We do talk about event sourcing and Saga pattern in detail there, and also eShop on containers have this implementation. So go and check that code as well.
Cool. All right, Nish. Well, I think that's about all the time we have. We do need to cut off before we get kicked off. So thank you so much for coming on, man. Like, this was a lot of great information. It sounds like we have a lot of stuff to read through, to experiment with, to play around with. Again, folks are in the chat or keep asking for the link. Please share the link so everyone can have to the weather API, the weather microservices demo, because I think people really want that. But again, this was just an introductory one. Hopefully we'll do some more on this particular topic of microservice and microservice patterns. If there's anything in particular, any particular patterns you'd love for us to focus more on in more detail, definitely leave a comment in the video below. And we'll try and take care of that for you really quickly.
Yeah, absolutely. Yeah, it'll be awesome if you guys just get to this and give us feedbacks, because we want to know what you what you really like to read, what you like from Microsoft perspective, what kind of documentation we want to do in terms of writing production ready apps, right? So if you just go into these links that we sent earlier, there are enough places where you can leave the feedbacks, and you know how to reach to us. So please make sure you do that, and happy to take up from there on. Thanks so much.
Cool. All right. Bye, everyone. Take care.
Take care. Bye.